Thank you very much, Mary Claire. It's a real pleasure to be with you this afternoon to talk about this very current topic. As you can see, the title that I've chosen for today is Zika Virus in the Americas 2015 to 2017, because we are still in a situation where it's still unclear as to what we're going to be seeing in the next couple of months. So for that reason, it really is interesting from a historic standpoint, but also from the fact of anticipation of what we can expect to see. So when Zika first became apparent in the Americas, the New England Journal of Medicine asked me to write a perspective on this, and I chose as my title, as you could see from this cover of the New England Journal of Medicine, Zika Virus in the Americas, Yet Another Arbovirus Threat, because what I was trying to impress the readership of the New England Journal was that although we may not be fully appreciative of it, but we have had several arboviruses enter into the Americas, into the Western Hemisphere, over the last couple of decades that had never before been in the Americas. And if you look at that, for example, in the 1990s, dengue, which is fundamentally an Asian and African disease, became entrenched in South America and is now seen in the Caribbean. Some of you may recall in 1999, West Nile, which had been in Africa and in the Middle East for centuries, first came to the United States, and it came either in the form of and I say this somewhat facetiously, but it's true, either a mosquito, a bird, and or a person got on a plane in Tel Aviv and landed at Kennedy Airport in New York, and now all of a sudden we have West Nile that's endemic in the United States, and every year we have a considerable number of cases. Then there's chikungunya, which was unheard of in the Western Hemisphere until 2013, when it landed in the Caribbean, including in Puerto Rico, one of our own territories. And then along came Zika, and that's what I'm going to be focusing on during my presentation. I'm going to divide it up into 4 components as shown here. First, a little bit of a background on Zika, for those of you not familiar with that. It's a single-stranded RNA virus. It's of the family Flaviviridae, the genus Flavivirus. This is important because although it is new to us in the Americas, we have a lot of experience with flaviviruses, such as dengue, yellow fever, Japanese encephalitis. And so not only do we know a lot about the pathophysiology of this type of a virus, but we also have made successful vaccines for other flaviviruses. The case in point, one of the most successful vaccines ever made has been against yellow fever. And we'll get back to that in a moment. Importantly, this is transmitted by a particular type of mosquito, the Aedes aegypti mosquito. Again, we'll get back to that in a second. Now, this slide in and of itself is a chapter in epidemiology. So for a place like the School of Public Health here at Maryland, although this is disease and none of us like disease, you got to really love this slide. Because in 1947, Zika was first recognized in the Zika forest of Uganda, hence the word Zika. We didn't know that it infected humans until 1952, when first human cases were discovered. And then it kind of went under the radar screen, and we know there were infections in Africa and Asia, but there was no distinct outbreak that we could identify. Now, that doesn't mean there weren't outbreaks, because in Africa, it's very difficult to distinguish between dengue and a variety of the other infections that go on there and an outbreak of Zika. But if it occurred, nobody recognized it. Until 2007, when there was a modest-sized outbreak in the Yap Islands in Micronesia, and then in 2013, an extraordinary outbreak in French Polynesia. 78% of the population got infected. That is huge for any outbreak to have that proportion. Again, we here in the Western Hemisphere didn't notice that. And this slide is a good slide, but it gets me in trouble when I show it to the Congress, because they say, Dr. Fauci, you knew there was an outbreak in 2007, and you knew there was one in 2013. Why are you only starting to make a vaccine now? And the answer to that is because we were not fully aware of what the implications of Zika were until it hit what I call the perfect storm. And the perfect storm was Brazil. Why is Brazil the perfect storm? First of all, it's a large country with a lot of people. There are a lot of mosquitoes. There's a lot of poverty and economic deprivation, particularly in the northeastern states. But importantly, they have plenty of Aedes aegypti mosquitoes, and they were completely immunologically naive to Zika. They had never before been infected. And whenever you introduce a pathogen into a population, a civilization that has never before seen it, you have very rapid explosive spread. Now, getting back to why we did not pay much attention to it, because Zika as a disease is relatively mild. You ask anybody in South America, except a pregnant woman, would you rather have dengue or Zika? Everybody would tell you, I'd rather have Zika than dengue, because 80% of the people are without symptoms. Those that are symptomatic have a transient degree of fever, rash, arthralgias, myalgias, and conjunctivitis, and it goes away, except for few exceptions. I'll get to why all of a sudden it became a very, very important infection. The modes of transmissibility are shown here. It's predominantly by mosquitoes, but as you'll see in a second, it's not just mosquitoes. And the typical villain in this is the Aedes aegypti. The Aedes aegypti is a particularly problematic mosquito because it only likes human beings. When you have other mosquitoes, they feed on animals and they get distracted. Aedes aegypti doesn't get distracted. It bites indoors, outdoors, day and night. So it's a very difficult and recalcitrant mosquito. The areas that are heavy for transmission are shown in the dark red in this map of the globe. And as you can see, the southeastern part of the United States, South America, Caribbean, the strip across Africa and into Asia. We also know that it can be transmitted intrauterine or perinatally to a child. And we know that from what we first recognized in Brazil, and I'll get back to microcephaly in a second. Now, this is an extraordinary virus. First of all, it's the only mosquito-borne virus that when transmitted to a woman during pregnancy causes a congenital abnormality. So that's a first. The other one is the only mosquito-borne infection that's sexually transmitted, another first. It's also transmitted by blood transfusion, which isn't a first, but that's something that makes control of this very difficult. So what about sexual transmission? Most commonly from male to male, male to female, also male to male. Female to male is documented, but is not nearly as efficient as male to female or male to male. There have been 13 countries that have reported sexual transmission. The reason is that similar to Ebola, the virus sequesters in the semen after the person has recovered from the systemic disease. And we have ample documentation of people who get a 7-day disease, they get better, and then for the next month or so, you can actually isolate Zika virus from the semen. You could isolate by PCR DNA up to 188 or more days. We don't believe that far out it's replication competent or infective, but at least for the first month or so, it is. Oh, what did I do wrong? There you go. Blood transfusion. As you might expect, any blood-borne infection is susceptible to being transfusion dependent, and in fact, it is. It's been transmitted and documented in Brazil, which has led us here in the United States to actually now screen the blood for Zika. And in fact, it's very interesting because in Florida, we found out, and I'll get to that in a sec, that because so many infections are asymptomatic, the prevalence of people who have evidence of getting infected is far greater than what you know about with regard to symptomatic infection. And there are some others, and these are outliers. I show them to you purely just to tickle your interest. We know that it can be shed in human breast milk. It's persistent for days after infection. Fortunately, there are no really truly documented cases of transmission from a lactating mother to a baby. However, as in most infections, it can be transmitted by a laboratory accident, and there have been documented. And then there's one really outlier case of a man in Utah who was one of those real rare cases who had overwhelming disease, was taken care of by his son, and the son got infected. Now you say, well, maybe a mosquito bit the father and then bit the son. They were in the mountains in Utah, and there were no mosquitoes around, so this had to have been because of the fact that the father was critically ill and actually died, and the son was taking nursing care of his father. All right, so let's skip to Zika in the Caribbean and Latin America. Right now, there are about 61 countries worldwide that have active Zika virus transmission. About 50 of them are in the Americas and the Caribbean. Here's where everything changed and why it went from a relatively inconsequential infection to something that has essentially captured the fear and the imagination of people living in this area. And that is a group of astute OBGYN physicians in the northeastern section of Brazil, in the states of Pernambuco and Alagoas, noticed that they had been seeing maybe 1 or 2 babies a 6-month period with microcephaly. We're now seeing several per week. And when they went back, they found out, as you could see from the bar graph on the far right, comparing the number of cases of microcephaly in Brazil from 2010 to 2014, and then look at what happened in 2015 and 2016. And this is a typical picture of one of those tragic situations of a baby whose mother was infected during pregnancy, most likely in the first trimester, but not exclusive of the first trimester. It isn't just the first trimester. We're seeing congenital abnormalities in babies whose mothers were infected during the second and even the third trimester. Now, the numbers are variable, but they're not at all inconsistent. A study was done in Brazil where they looked at mothers who were infected during pregnancy but were symptomatic. Namely, they were clearly had infection, which means they probably had a viral load that was pretty high. 40% of the infants born to these symptomatic infected mothers had gross abnormally normal clinical and or brain imaging studies. The numbers that are reported about any degree is anywhere from 1 to 13%. And some of you may have read in the Washington Post about 3 days ago, where of the women who had babies that were born in the United States, they were infected either in South America or Puerto Rico. They came to the United States, they gave birth to their children, and 10% of them had congenital abnormalities. So it's somewhere around 10% or 15%, but if the mother is symptomatic, it's even higher than that. The other thing we learned, that a baby could be born with a normal-sized head, but as the baby developed in the first months of life, you started to see the development of microcephaly because the brain stopped growing. And the reason the brain stopped growing was because of the destructive effects of the virus. And we know now something we did not appreciate when we thought the only lesion was microcephaly, that microcephaly is just the tip of the iceberg, and babies who are infected during the intrauterine period have a whole host of other types of abnormalities. The temporal relationship is very clear. Some of you may remember there was an argument that microcephaly was due to environmental toxins and things like that. That was all a bunch of nonsense, which we knew right from the beginning, but a lot of people were coming up with that. If you look at the blue line is the pregnant women who had virus infection, and predictably 9 months later, you get the red curve, which are babies that are born with microcephaly, something we had never seen before in that part of the world. We don't talk about microcephaly in a vacuum now. We call it the congenital Zika syndrome. For those of you old enough in the audience to remember the 1960s, we had the congenital rubella syndrome, which was almost the same thing. Rubella is a relatively mild infection. Children get it, they recover, and then they're immune, except if you're an unlucky young girl and you didn't get infected when you were a child, and then you are in childbearing age, got pregnant, and then got rubella, then you had a danger of your baby getting the rubella. It's the same sort of thing. And with the congenital rubella syndrome, congenital Zika syndrome, are a whole host of other abnormalities besides microcephaly. Hearing loss, visual abnormalities, things like ventricular enlargement, a condition called arthrogryposis, which is a contraction of the joints in the hands and the legs. And here's a picture, tragically, of a baby who has arthrogryposis in the legs and in the arms. And this is what they have been seeing now in Brazil and elsewhere. If you look at the retina of an individual who has Zika infection, it is very reminiscent of cytomegalovirus infection and what looks like in the destroyed retina of this child. We also have Guillain-Barré syndrome, which is not surprising because Guillain-Barré follows a number of viral infections. Certainly, it follows and is associated with Zika. And as you could see, the Zika infections on the top panel in green, and the Guillain-Barré syndrome within a week or so of the initiation of the Zika infection. There are some outlier infections, such as acute myelitis, and again, I show you these. These are very uncommon, but they occur, which tells you something about the neurotropism of this particular virus. It's particularly neurotropic for primitive neuronal cells in a fetus, but it also can be neurotropic, as shown in this case of acute myelitis and a case of an acute meningoencephalitis in an 81-year-old French person who lives who got infected in a cruise in the Pacific. There's hearing loss, similar to what we've seen in the rubella syndrome, transient hearing loss in adults. The thing that just came out last month was something that was pretty disturbing that we didn't appreciate before, namely myocarditis and heart failure with arrhythmias in 9 Zika-infected individuals, 8 of whom had this abnormality. And what this tells you is that when you're dealing with a brand new disease, only when you get a very large number of cases do you see the full spectrum of disease. Because remember, in 2007 and in 2013, when there were these cases in the Yap Islands and in French Polynesia, people thought it was just a plain old flu-like syndrome that went away. It's only when you get thousands and thousands of cases do you see the unusual manifestations such as shown here. Now, what about the United States? So when I testified about 18 times, I'm not kidding you, over the period of a year in front of the Congress about what we were doing about Zika, one of the congressmen told me, he said, Dr. Fauci, why don't we just cut off any kind of border crossing, just don't let anybody in from South America or Central America. So I looked it up and got back to him and said, well, that wouldn't be very feasible because there are about 216 million people a year go back and forth between South America, Central America, and the United States. So any idea about blocking entry into our borders is a fool's errand. So Puerto Rico did get hit pretty badly. In fact, the epidemic in Puerto Rico was really rather tragic. It was very similar to the chikungunya epidemic. So how does it get to the continental United States? If it's in South America and in Puerto Rico, and the way it happens is, I think, a good lesson in good public health epidemiology. You have travel-related cases. So in the continental United States, there are over 5,000 travel-related cases. What do I mean by travel-related cases? That means someone who lives in South America or Central America or the Caribbean gets infected and comes to the United States, or somebody that lives in College Park and goes down to Brazil to give a talk or goes down on vacation, gets infected and comes back and still lives in College Park. that's travel-related. When you have the right mosquitoes, which we have particularly in the southeastern part of the country along the Gulf Coast, and you have travel-related cases, inevitably, you're going to get a local transmitted case. So I said before the press, some of you may have seen me or heard me with the press saying, I will guarantee you that we will have a local transmitted Zika infection. And sure enough, we did. There were over 400,000 in Puerto Rico, and Puerto Rico, going back and forth between Puerto Rico and Florida, for those of you who have ever been to Miami Airport, it's like Grand Central Station between San Juan and Miami. And in fact, that's what happened. So there were about 1,600 pregnancies, and that's where we got the 10% of those pregnancies wound up having congenital abnormalities. But here is what happens with local transmission. Particularly in Florida, there were 216, now it's I think 218, individuals who never left Florida, who were bit by a mosquito that bit someone who was a travel-related case. There were about 40 sexual transmissions in Florida, mostly around the Miami area. So there are about 260 cases in Florida and about 6 in Texas. There's a town in Texas called Brownsville, which is right on the border between Texas and Mexico. And that town gets everything that Mexico and the Caribbean gets. That's where they had an outbreak of dengue. That's where they had an outbreak of chikungunya. And Brownsville is where they had a small, mini 6-person outbreak. Now, what about the response to Zika? I say NIH response, but it was a variety of public health responses to Zika. So at the NIH, since we're a research institute, we do fundamental basic and clinical research, diagnostics, and then we try to develop countermeasures in the form of vaccines and therapeutics. So to look at some of the basic research findings, which were really rather interesting. The big question is, why is it that this virus is tropic for neuronal cells? And we found out the receptor for the virus on neuronal cells. So if you looked at a mouse model, mice do not get naturally infected with Zika, except if you immunosuppress them by looking at a genetically modified mouse that has a defect in interferon. That mouse becomes extremely susceptible to Zika. So we looked at the mice that were infected, and we looked at the mechanisms whereby the virus was able to bind to and destroy neuronal cells. We then went on to develop a rhesus macaque model, which has been very, very important in looking at the interesting issue with pregnancy. We found out that for one reason or other, pregnant women who get infected with Zika, whose fetuses get infected, unlike 7 days of viremia and then you're done, women had sustained viremia for 20, 25, 30 days. And what was happening, that the fetus that was infected was reinfecting the mother. So the virus was spilling over back into the mother's circulation. So the mother seemed to be well because the mother had developed a good immune response. But the fetus was in trouble and was spilling virus over into the mother's intravascular space. The other thing that we're following now, and I don't know what this is going to mean, whether this is going to be a real problem or whether this is just mouse-specific and has nothing to do with human reality, that in studies done by Mike Diamond, who's one of our grantees, that if you infect adult mice, they get testicular atrophy and oligospermia. So we know that the virus stays in the semen for a month or so after. What we don't know is if this has any impact on adult men who are getting infected and think it's just a mild viral illness, and they wind up with oligospermia. So what we're doing is that we're following men right now and doing semen samples, not only to see if the virus is still there, but to actually do sperm counts and find out if they are actually oligospermic. Vaccines is the big thing that we've done, and this is an example of how preparedness with other diseases helps you. This is a busy slide. I don't like busy slides very much, but I just wanted to make the point that we have 5 candidates that are in various stages of clinical trial. The first one is a DNA vaccine candidate For those of you not familiar with that, you take a plasmid of DNA and you insert a gene or two of Zika that expresses important proteins, and you inject that into someone. You make an immune response against it because those proteins, thank goodness, turn into what looks like a small viral-like particle. And we were successful with West Nile with that, and it looks pretty good now for Zika. It's very interesting, and that's the picture on the left of the plasmid. The blue is the core DNA, and the yellow is the gene that encodes for a Zika outer protein. You inject it into a muscle, virus-like particles are produced, and the body makes an antibody response. Some of you may or may not have noticed about a week and a half ago, I made the announcement that we started a phase 2 trial, and we started it in Houston, in Miami, and in Puerto Rico, and probably in June or July, we'll go to a 2B trial in Brazil, Costa Rica, Panama, and Mexico. So if there are cases there, we may have the opportunity in a very easy way to actually prove the efficacy or not of the vaccine. So this is rocket speed for a vaccine to go from essentially a new disease and have a vaccine in a phase 2 trial, which I think tells you something about the entire field of vaccinology. 15 years ago, 20 years ago, it wouldn't have been 5 years before we were at the stage. Now, we're going into an advanced efficacy trial within a year of starting to do it, which is the way things are going to be going in the future. Clinical research, this is an important study. It's called the Zika in Infants and Pregnancy Study, or ZIP. It's a collaboration with the National Institute of Child Health and Human Development, in which we're prospectively looking at a cohort of 10,000 pregnant women. Whether you get infected or not, just pregnant women come in the study, and then you follow who gets infected, what % of the babies are involved, and even in the babies who are well, and you think they're well, are they really well when you follow them for a year? Because the big question is, a baby looks like they're born normal. What about their benchmarks, their landmarks at 6 months, a year, or what have you? So that's going to be very important. So I'll end with a question, because it's an interesting question. Will Zika reemerge in 2017? And the answer is we don't know. We will see Zika cases for sure, because we still are seeing Zika cases in South America and in Puerto Rico. But will it reemerge in a second wave of an outbreak? We know that dengue definitely has, and we know that chikungunya definitely has, but it's unclear whether or not Zika will. And that's the reason why we're scouring around making sure we get our vaccine infrastructure set up so that in case it does happen, we'll be able to address it. And I want to close with showing you this slide that is a slide made from a paper that my colleagues David Morans and Greg Folkers and I wrote about 9 years ago. And the title says it all. It says, Emerging Infections, a Perpetual Challenge. And I think that just looking at what happened with Zika and what happened with the other arboviruses tells us that we've always had emerging and re-emerging infections. We certainly have them now, and we absolutely are going to have them in the future. Thank you.
Please join me in thanking really one of the world's experts in infectious diseases and vaccines. Does this work? It is. So we have time for question and answer until 4:10, at which time I will have to close that question and answer. So now is your opportunity, both students, faculty, practitioners, to ask Dr. Fauci a question. And I'm sorry, would you please give your name and introduce yourself briefly?
John O'Brien with the advisory board here, Doctor. So what advice do you give to childbearing age women in Miami right now?
That's a good question. Right now, the activity is very low, but during the major part of the activity is that if you are of a childbearing age, there's a certain region in South Beach around Miami where since there's still active transmission, that if you are planning on traveling to that, don't travel there. So pregnant women should not travel to that particular small area. If you're a pregnant woman and you happen to live there, that you should do everything you possibly can to protect yourself against mosquito bites. And there are really some pretty good ways to do that. I know it's very inconvenient sometimes, particularly in the warm weather, but to try and stay indoors with air conditioning, to use 30% DEET, and to wear clothing that covers most of what you... There are a lot of women who decide they don't even want to take that risk and who actually leave during their pregnancy, go to a place where there isn't any, but that's not an official public health recommendation. The only public health recommendation is a travel alert for people from the outside to go there.
Next question. Amelia?
Thank you. Have you thought about anything related to vaccine hesitancy when it comes to the potential Zika vaccine?
Vaccine hesitancy? With Zika or with any vaccine?
With any vaccine, but Zika in particular, like are there any special concerns for these populations?
No, actually, there's a lot of enthusiasm of people wanting to participate in the clinical trial, and there is a great need in the governments in those areas for us to come up with an effective vaccine. So I see a lot of enthusiasm about moving ahead with vaccine development and ultimately getting a vaccine. You look surprised.
No, that's really great to hear.
Yeah,
Hopefully the United States will follow.
yeah, yeah.
Stephen Thomas, I'm a professor in our Department of Health Service Administration. I've watched you on TV. I trust you. I believe you. And my question is, what do we do in the context of an environment where we don't have that kind of trust, where there's strife either in a country or misinformation in this country, where there's competing messages about what to do and the etiology of these diseases? Is that a concern, and if so, what role do we have to play in public health to address it?
Well, we should get rid of social media, but no, just kidding. That's a very good question, and I have an example of a very serious disease outbreak that I was very intimately involved with, in which, understandably, trust was very low for good historical reasons, and that was the outbreak of Ebola in West Africa, where the West African countries of Guinea, Sierra Leone, and Liberia had suffered for years under great turmoil, civil war, oppression of authorities. And when authorities came in to try and help with a disease that they really wanted to help, they didn't trust us. They didn't trust anything we said. You know, we were outsiders, authoritarian figures, and they just didn't trust us, which made things really worse. And that's how the epidemic, until we finally, over a lot of hard work, was able to establish trust with them, that we're able to work with the local community to get the epidemic under the control. But a more broad answer to your generic question is that as scientists and public health officials, we're completely evidence-based, and we can never get away from evidence-based. And whenever we interact with the public, with the media, with government officials, we've got to stick to our guns that we go by what scientific evidence tells us to do. And if you do that, and you do that consistently, you can build up trust. But it isn't easy. I mean, I'm saying it like it's easy, but it's not.
Yes, sir.
Yeah, I'm Tom Jones. I'm actually from civil engineering. I just want to thank you for your work 30 years ago into Wegener's granulomatosis, because you standardized the cyclophosphamide therapy, and it saved my life. Thanks.
Oh, great. Thank you. Thank you very much. It's in the field that I am right now, I don't frequently get that kind of a personal thank you. Thank you. It's great to see you looking well.
Okay, so we have a question.
Oh, we got one right there, Sandra.
Okay. Jake? Oh, me? Oh, I'm sorry. I'm sorry.
Hi, I have
Red
a
light
question.
first, then
How do you give the hard facts without hysteria arising? And how do you equip people with information so that they can be accountable for their health when it comes to these infectious diseases?
Well, it's kind of somewhat of a derivative of the answer that I just gave to the other question. It's just to be as honest as you possibly can. The thing I've learned over many years of dealing with these outbreaks is don't guess about things. If you don't know and you can't project accurately, say at this particular time it's unclear, and you'll get respected for that. Because if you say something and you're just trying to make people feel, there are two parts of this bipolar approach. One is everybody starts exaggerating everything and the sky is falling. And there was so much of that, people saying Ebola is going to be airborne. There was a big New York Times editorial written by somebody who should never write an editorial, saying that Ebola was going to go airborne. On the other hand, you don't want to underplay something. So you have to be absolutely truthful. And if something is very serious, you've got to explain that it is serious with all the facts. And if it's not, you just don't make something out of it that it's not. And you have to stick by that rule, because once you lose credibility, you're done. No one will ever believe what you say again.
Thanks, Dr. Fauci. So one of the conversations that we have going on a lot at this university is how we develop a workforce and students that are both critically thinking and ready to take on the big challenges that we're facing globally. And what advice would you have for our university and or universities in general, as well as public health institutions, practitioner-based institutions, to assist with developing this prepared workforce?
Well, I think you should first start off with realizing that the field that you're in is I'm speaking, I can't speak too objectively because I'm in it, has to be one of the most exciting areas of endeavor you could possibly think of. Global health. It's health, which is critical to every human being, and it's global, which means it's really big. So I think if you start off with the premise that you're dealing with something very important, then you could generate a lot of enthusiasm on the part of the students, around the fellows and the pre-docs and the postdocs, that you're really in a very, very exciting field. And regardless of occasionally you have people who come in and out who don't think that much of it, but the issue of public health and global health is a magnificent area. Not everybody can say that. It's not a big money-making area. You're not going to make $1 billion doing it, but you can have an enormous impact. Just the idea that you could impact thousands, if not millions of people is, kind of breathtaking, I think.
Yes. Where are we?
When researching patients with Zika, is there a way to tell whether the patient was infected via mosquito transmission or a sexual transmission or another method?
The only way you could tell that is epidemiologically. And let me give you an example of that. Is that some of the sexually transmitted cases was a man, this is a true story, I won't give their identity, a man who was down in Brazil who got infected, came back to New York City and had sex with his wife. She had never left New York City. There are no Zika, there are no Aedes aegypti mosquitoes that could transmit it in New York. She got infected. So absolutely, she got infected by sexual, he got infected from a mosquito because he didn't have, and I took a good history, we took a good history, he didn't have sex while he was down there, so he didn't get it from sex. So that's pretty easy. But it's all epidemiological. It's not anything specific about the virus. So once you get viremic from a mosquito bite, it's the same viremia as from sexual transmission.
Yes, ma'am.
My name is Joanne Dorgan. I'm a professor in the Department of Epidemiology and Public Health in Baltimore. And I was wondering if anybody has considered or looked into de novo infection with Zika after birth and potentially more subtle developmental or intellectual disabilities later.
So that is a great question, and is a question that I have gotten asked 1,000 times by people who have infants who they are saying, I'm not going to get pregnant again, but I have a 4-month-old infant child, and I want to go down to Brazil to see my mother-in-law or something like that. Is there any danger if my child gets bit? And the answer is, from retrospective cohort observation, there doesn't appear to be. But we don't know for absolutely sure if a child from birth until when they stop developing a brain, whether or not they are susceptible to the kinds of subtle things that you're talking about. We don't think that's the case. In fact, we think that the reason why fetuses get brain damage is that there's a certain interaction of the virus through the placenta to the baby. Whether or not a baby who gets bit and gets the virus injected directly into their blood from a mosquito doesn't seem to have any deleterious effect, while if you get the virus through the placenta, that you can. And I'm saying that as observational, but not a controlled study looking at it. So it's still an open question. And that last study I showed on the next to last slide, that Zika in infancy and pregnancy study, we're going to extend that to look at babies who might have gotten bitten and infected after birth to answer that question.
Dean Lusniak?
Boris Lushniak, Dean of the School of Public Health, thank you again for taking on this mission to be here, and certainly your critical role in public health for the good of our nation. I'm going to pose a question that sounds like it has religious overtones, and in fact it may have, right? Which is, in your critical role in public health, how do you convert agnostics or non-believers in science to at least a viewpoint that is a little different than perhaps currently held?
Okay, so that's a good question, and there are various versions of non-believers in science, from the anti-vaxxers to people who just don't believe in science. So my experience, Boris, has been that if you look at a cohort of anti-sciencers or anti-vaxxers, there are some people who, no matter what you say or do, you're not going to change them. But there is a proportion of individuals, if you reason with them about the rational approach of science, and that science could be the efficacy of vaccine that doesn't cause autism, that you will convert these people to a more rational approach. The one thing that never works is when you're very critical of them and very demeaning of them, like you're stupid because you don't believe in science. That never works. So you have to, even though deep down you're saying to yourself, you're stupid, you really want to say that you have to respect the fact that they feel that way, and then get to them so you don't have an adversarial role. Because whenever you have a scientist talking to someone who doesn't believe in science, it's almost a perfect setup for an adversarial role. If you break down the adversarial role and say, I understand how you feel and I respect it, but let me tell you why I think it's different, you can win over a certain percentage of people. Not everybody, because there'll be a core people, no matter what you do, they're not going to change.
And as a follow-up, is the same approach utilized for politicians?
Yeah, no, in fact, that's where I learned all that.
Where'd it go? It moved. Okay, it was there. I know.
My name is Anna Long. I'm a prospective student here. I was wondering if you think there's any success to be had in controlling Zika through controlling the mosquito populations, or Zika within the mosquito populations as opposed to the human population.
Yes, so the answer is yes, 10 times over. The major intervention that we had during the major outbreak in Brazil, South America, and in Puerto Rico was exactly that, was mosquito control. And if you control mosquitoes with spraying, with larvicides, with adulticides, with a variety of other chemicals, and control them, you could actually have a quite clear-cut, measurable decrease in the rate of infection. In fact, what we're doing now, and this has some degree of environmental sensitivity because people are a little bit concerned about it, is you could release genetically modified mosquitoes into the environment that turns out making all of them sterile so they don't reproduce. The other is infecting mosquitoes with a bacteria called Wolbachia, which is interesting. It's a bacteria that infects mosquitoes that doesn't allow them to transmit these kinds of viruses. So the short answer to your question is that mosquito control is not only a way, it is the way to control this disease.
Yes, ma'am.
I'm Pat McLean from the School of Nursing in Baltimore, and my question has to do with this interesting case of exposure from patients to family members. So I'm wondering about the question of caregivers, both in the hospital and in the community, and what do you think is needed to protect people from exposure and so we don't have repeat situations like we've seen in other diseases?
Yeah, well, it's a confounding question for the following reason. Very, very few people who get Zika infection get sick enough to require an intensive care type of an interaction. So the one situation where it was that man that I told you about, whose father was extraordinarily ill, and we can't still figure out what happened with that father, who the son was taking care of him, nursing him. So that made us say that what we should probably do when you do get the very, very rare case of an ICU Zika patient is to do just universal precautions, the way you do as if the person had hepatitis or had something like that. But there's no recommendation that you go into a full Ebola mode where you put a spacesuit on. There's no reason to do that.
Hi. So regarding the vaccine, I know you haven't fully developed one yet, and I guess it might depend on when it is fully developed, but how accessible would that vaccine be to, say underdeveloped countries or countries where Zika is prevalent, and like would you prioritize certain populations over others? And then, in the United States, in areas where we have seen cases, would it be, required, or I guess that's my question.
No, those are good questions. Are you a student here? You're making me feel extraordinarily old. I'm looking at you, and you're a child. That was a great question, and no, it really is. In fact, it's a major policy issue, and it is the following. Vaccination would be of a specific population. For example, if a woman was of childbearing age and they needed to go into an area where there was Zika, you'd want to vaccinate that person. We don't see vaccination for Zika to be appropriate or relevant in a country like the United States, where there's very little risk of Zika becoming endemic in the country to the point where there's such a risk to women of childbearing age. The critical issue with vaccine that you got to remember is to protect women of childbearing age. So what I do see Zika vaccine possibly being implemented is if we get endemicity in Brazil or in Colombia or in Puerto Rico, that you might want to vaccinate young boys and girls the way we do with rubella, so that by the time the girl gets to be of childbearing age and her sexual partner, the boy who could transmit it to her, because we know it's sexually transmitted, you'd protect the population. So I don't see it as a polio-type vaccine. I see it in certain countries where there's established endemicity, and for individual cases of travel-related or circumstantial, where if you wanted to take a postdoc in Rio de Janeiro and you were of childbearing age, you might want to protect yourself with a vaccine. But I wouldn't give it to the University of Maryland students in general, right?
So, Paul, you have the last question.
I'm Paul Turner, Assistant Professor in Environmental Health. I had a question that related back to what you said at the very beginning, was that you were criticized for not being able to predict this in 2013. And I'm wondering, with the 4 years of experience in how the epidemiology has progressed, whether you're now able to better predict some of the new infections that you're talking about with your very last slide, so that you can then intervene at an earlier stage.
Yeah, well, it gets back to what I said. The answer is, yeah, of course you'd like to have more knowledge to be able to predict what it is, but the interesting thing that was peculiar about Zika is that it only showed its real deleterious effect in a very special circumstance. So we had no way of knowing. In fact, we discussed this in 2013. I could never have gotten any money from the Congress to develop a Zika vaccine for a disease that everyone perceived was a febrile illness that lasted for 5 days. There was no way that they would say that would be such a low priority for a vaccine. Once it got into the babies, boom, it exploded. Obama asked for $1.9 billion for us to work on that. So I'm not sure that the experience here would help us. It depends on what the next infection is.
So first, for the students in the room, you've truly now been and had an opportunity to hear from and ask questions of really one of the giants in public health and infectious disease. And for all of us, please let's join in thanking Dr. Fauci.